this point right now, you should have written down, if you're choosing to write down, you should have written down, what is it? Probably lots of you wrote it down already, right?
Yes, I did.
Yeah, I know you did. I want you to write down what you think physics is, right now.
Airplane.
Write down what physics means to you. No wrong answer because it's your opinion. Go. I need you to pick a number between 1 and 31.
16.
Nate Urey, that's what the number is. Nate! Alphabetically. Tell me, what is your answer? What is physics?
For every action, there's a reaction.
For every action, there's a reaction.
A law.
You didn't even finish that.
Yes, you did.
That's a law. That's not what physics is.
Which law is it, you know? It's one of Newton's laws, you're right. Physics is a little bit more than that. That is a small portion of physics. Okay, anyone else? Lucas says how stuff works and why. He is looking it up on her phone. What'd you get? Oh, you're not looking it up on your phone. Oh. You're texting your mom. Your mom is in school and she doesn't need to be texted.
I know.
Claire,
Texted.
she texted you?
No, I said she's going to text me at the end of the day, so I can...
Oh.
We're recording all of that.
I know. It's going to be great fun to watch at home. Okay. Claire, what's physics? No, nothing?
Energy.
Energy? Jason?
Motion of objects. Written down as math.
How many people think it has something to do with motion of objects?
It is general analysis of technology.
Yeah, and that's usually the answer I get, and I'm here to tell you that that's a small portion of it.
Study of matter.
A small portion of it. So, if you go to the dictionary, boring, it will say something like, physics is the study of matter and energy and their relationships. And yes, Sheldon will nod and say, if you're one of those people that wants to write things down, you should write it down. Physics is the study of matter and energy and their relationships. Does that pretty much cover everything? What's matter?
Everything around it.
Yeah, everything. Everything you see in the room. People, pens, papers, computers, birds stuffed weird up on the shelf. Everything in the room is made out of matter. Does everything in the room have energy?
No.
Yes.
Some of you probably have more energy than others. Do the pen... Go ahead.
Everything has potential.
Everything has potential energy. Let's talk about the crazy stuff bird on top of shelves. Does it have potential energy?
It had.
Well, it had, okay, fair enough. But does it right now have some sort of potential energy? Yeah, it does, because it's up there on the shelf, and if Nate were to go up there and try to climb the shelves and knock it over, and it landed on Gage's head, well, it would hurt. And it would accelerate at how fast?
Oh my god.
Come on, you're watching the video?
Oh,
9.8 meters per second squared. Study of matter, energy, and the relationships, okay. There's a whole lack of internet definitions here that all basically say the same thing. I won't bore you with them.
Is that the speed at which everything accelerates at?
Yeah, everything falls at 9.8 meters per second. Sorry, everything.
Not 9 meters off the ground.
Pardon me?
It's not 9.
No. What that means is that's a really good question. I got to do this here, so I can. Yeah. Okay.
It would take less than a second to hit the ground then.
What it means, Lucas, and we're going to talk more about that when we get to acceleration. But you've asked the question, so let's open that can of worms right now. When something falls, when I drop, I usually have tennis balls lying around just for this very purpose. When I take out a tennis ball and I drop it, does it fall at 9.8 meters per second? Is that what Sheldon's saying? No, not even close. At the start, like the instant I let go, it doesn't go to 9.8 meters per second. At the instant I let go, it has to go from 0 meters per second. It has to travel through like 0.1 and then 0.2 and then 0.3. It has to speed up, is it not? Okay. And that rate that it speeds up is 9.8 meters per second every second. So I go from 0 to 9.8 meters per second in 1 second. That's what that acceleration is.
What about things that are parachuted?
Great question. When things that are parachuted, if you jump out of a plane like Mrs. Gennick did over Switzerland this summer. Did I tell you that?
I just wanted to stick it to
She told you that?
Video.
She showed you the video?
Yeah.
Oh, I didn't see that.
So
So when she's out with her parachute, her surface area increases dramatically. Have you ever gone down Main Street, stuck your hand out the window, and done this?
Yeah.
Nobody's done that?
No.
Yeah, it's so much fun, right? Okay, now if you stick your hand out like this, straight, what happens to your arm?
Get hit by a car.
Well, yeah, don't do that. Right? But if you're going down Main Street, you can put your hand out and you kind of feel it push back a little bit, right? But if you're going down the highway and you do it, what does it feel like? Like you might actually hurt yourself, right? The faster you're going, the more resistance there is. And so when you have that greater surface area of parachute, greater surface area, she's falling fast. Eventually she reaches what is called, anyone know when you fall and reach a constant speed?
How come you don't fly farther? How come you don't fly farther than a piece when you're skydiving?
Because, like, how come you're not going faster and faster and faster and faster?
Yeah, but when you're not parachuting.
Like, if you're just skydiving with no chute open, why would you fall apart?
You
Oh,
can
because of the air resistance, you mean? Is that why? Okay. A human, even without the parachute, Lucas, eventually will reach what we call terminal velocity. Okay? You can only fall so fast. That 9.8 is only really true in a vacuum, when there's no air resistance, no atmosphere. Okay? So even a human, and a larger human, when they jump out, if you had a large sort of wide human and you had a much smaller human, maybe a child, right? The child would actually go faster than the larger person.
How do they fall at the same speed?
They do, but see the weird thing about physics is that there's always kind of a friction is a real pain. Friction causes a lot of problems, right? So lots of those theoretical things are only true in a vacuum.
What is terminal velocity?
Terminal velocity is, are you asking me the number? Okay, it depends on how big you are. So like tennis balls have a different terminal velocity than even say like a bowling ball, right? Depends on how smooth they are, how big they are. Even probably might depend upon the humidity and the air pressure that day too.
But then again, there's ISS and stuff like that out in space, but then they're still in the gravitational pull of Earth.
Yeah.
They reach their terminal velocity, because in theory, they're still falling to Earth, but they're going around.
Okay, you're about 3 units ahead of us. They are falling at terminal velocity, you're right.
Because actually, my old science teacher told me that
Yeah.
if he stood up out there, like if there's a giant elevator platform,
Yeah.
he would stand. But
Yep.
ISS per second, it would be going faster.
Yeah, very fast. Absolutely. We'll get to that eventually. Few weeks down the road. We'll get there. Okay, so in here, in regular grade 11 physics class, what knowledge, skills, and attitudes do you need to study physics? Jot down 2 things that you think you need to be able to do in here in the next 5 months. What are 2 pieces of knowledge, 2 skills, or 2 attitudes that you need to be successful in the next 5 months?
Diligence.
Write it down, don't yell it out. Who's got something for me? What kind of things do you need to know? Math skills. I heard someone say calculator skills. If you can't use a calculator, you're going to be in trouble.
I'm not scared.
You need a calculator. You're going to need it real soon, like by Monday.
Walmart's out of them.
Cole, give me a skill. Something you need to be able to do. Hey? You need to be able to, okay, study, take notes, summarize maybe. Confidence? Yeah, like, you got to have some confidence in your abilities. That's right. And I know that you can all do this. Graphing is important. Computer skills, we're going to be graphing on the computer. Chandler, anything? Positive, right? Yeah, absolutely. I mean, that goes for anything, I suppose, right? Carly? Pardon me? Organize? Yeah, organization is pretty important too. Absolutely. Diligence? Okay. I made a list.
Well, those are all boring.
Yeah, I made a list. I would say yours are just as good as mine. You need to be able to experiment. You need to be able to measure stuff. You need to be able to analyze stuff. You need to have basic mathematical knowledge and skills. You need to know when you should use your cell phone and when you should be listening. You need a creative attitude. You need a bit of luck. You know the old story about Graham Bell, right? And Watson, come here, I need you. It sort of just happened magically. You need some imaginative attitude, creativity, trial and error skills, estimation, patience, It's not going to come the first time every time. It's going to take work. You can write as many of those down as you want. I don't care. Will you be able to come up with 2 or 3 if I ask you? Yeah, I think so. All right. What's the difference between the physics that you're going to be doing for the next 5 months, high school physics, and studying physics at the university doctorate level where Sheldon works?
It's not gonna be as hard.
That's one difference.
Kind of look on the surface of things, don't get really in depth on anything specific.
Okay. There's one key difference that, you know what, in all my years of teaching, I've never had a kid come up with that I remember. I'll try. Jason and then Alex.
The scale of which they work.
That's kind of like how difficult it is, right? Okay. That's not what I'm thinking of, but good guess. You must have read my mind. That's exactly it. Everything you do in here is something that I taught it last year, right? It's not new. The textbook says, it's always a joke, Modern Physics, published in 1990. First published in 1968, the year I was born. It's not modern. Has physics been around a long time?
You say you're not modern.
No, I'm not. Has physics been around a long time? Yeah, he's talking about ancient Greece, right? Modern physics, that's like, yeah, stuff from the last 500 years. Alex is absolutely right. All the stuff that you're going to do, all the experiments that you're doing, are they really experiments? Well, they are. You're discovering it for the first time, right?
But they're qualitatively similar.
Yeah, it's exactly the same, right? I know exactly what's going to happen. I know the mistakes you're going to make. I know what the graph's supposed to look like. I know everything about it. I've done it 1,000 times, right? The experiment that Sheldon's doing, does he know what the graph's going to look like? They're discovered. They're on the edge, the new frontier. Okay? Your journey has just begun. Now, having said all that, it'd be really cool if someone in here came back a few years from now and said, hey, I'm doing this really cool experiment, and I'm learning about this. Okay, so yes, Alex was right. High school students learn about accepted theories and concepts. Doctorate students investigate new physics. They do experiments that nobody knows the answers to. They discover new things. That's real science, is it not? I would say so, right? That's real science. Do you need to know that?
Sure.
Yeah, probably. Do you need to write it down to know it? Probably not.
Whole thing.
And you can have a little bit of fun too, right? We will do some fun stuff as well. Some fun labs. Now these guys, do they do science?
Yes.
Who doesn't love the Mythbusters show? Nobody. Is it not one of the best shows on TV? You can pretty much always watch an episode, right? They're always doing something cool. Blowing something up, right? Ramming a car into a wall or whatever. Do these guys do real science? Absolutely. They are literally almost the Isaac Newton and all those guys of our era. They're doing science and bringing it to the masses and showing it to TV and actually making it kind of popular too, right? I think so. They're doing real science. Pardon me? Oh, a long time. That would be like my dream job to work on that show. That'd be awesome. Be lots of fun. Okay, I'll stop.